Volatilization gravimetry is a technique used in analytical chemistry to determine the amount of a substance in a sample by measuring the mass of a volatile compound. So we have here an illustration of volatility in terms of chemistry. So we have a volatile substance is one which readily vaporizes, as we can see in the illustration. So you have your volatile and your non-volatile compounds, wherein in our mass or in our prepared sample, you can see that the non-volatile components are still in your sample or in your prepared solution, whereas the volatile compounds will readily evaporize or diffuse in the atmosphere. So typically, your volatile substance has low boiling point and high vapor pressure. Volatilization gravimetry. This is actually a method wherein particularly it is useful for substances that can easily vaporize under controlled conditions. So even at room temperature, and then eventually you subject it to thermal heating. So it can be heated or chemically treated too, so that your volatile components will vaporize or it will be lost in the sample's mass. We have here examples of volatile organic compounds. And there are actually different characteristics of volatile compounds. We have high vapor pressure and low boiling points, as well as most of these compounds are organic in nature. So example of these volatile compounds, so you have your ketones, particularly your acetone. As we have observed, acetone is commonly found in nail polish remover, and acetone can easily vaporize in the atmosphere even if subjected to room temperature. So let's go back to the characteristics of volatile compounds. As I have mentioned, they have high vapor pressure, which means they have a tendency to vaporize quickly even at standard temperatures and pressures. When we say that they have low boiling points, it means that these compounds generally have low boiling points, allowing them to evaporate easily. So some of these compounds or most of these compounds will vaporize even below 100 degrees Celsius. And most of these compounds have carbon atoms, making them organic in nature. And volatilization gravimetry is actually commonly used to, for example, determine the moisture content in materials by measuring the loss of water upon heating, as well as analyze inorganic ash content of organic materials such as polymers, paper. So the method can be by combusting it in a furnace. So we have an equipment called the furnace. So you can actually ignite or combust these materials, or specifically the organic matter, and weigh the remaining ash in order to obtain its inorganic ash. The last one is to assess the purity of substances by measuring the loss of volatile impurities during heating. And we can also include this in our sample preparation method, especially if you have unwanted volatile compounds that are present in your sample. We have here an example of a schematic diagram, specifically determination of ash content. So here we can see the flow of this process wherein This is already the method, but if you have a sample preparation of your sample, so it is actually, uh, it depends if you have it using its dry mass or its wet mass. So if it's okay to use the wet mass of the sample, or just after homogenizing it, you can subject it to this method wherein we determine the ash content of the sample. And then the principle here in this method is actually to heat it. So as you can see, we have used a muffle furnace and subject it for 2 hours at 600 degrees Celsius. So this actually has an effect on the sample wherein you subject it to heat or treated it with a chemical reagent to cause the volatile components to evaporate or decompose. Then after the vaporization of these volatile substances, so they're already out of your sample, so you can actually get the mass of the collected volatile product and measure it using the analytical balance here. And of course, if you're using a crucible, so you must obtain the constant weight of the crucible so that there are minimal errors in terms of your weighing. Then we calculate the weight of ash and the percent of ash content. In the calculation, we will be able to know the amount of volatile component as well as the percent ash in our sample. And we can actually use the existing formula for this standard method. But first, let me show you a sample data table. So here you actually need to get the weight of your sample. So as I have mentioned, you can use the after homogenizing. So it's okay if you have the wet sample, or for example, you have a plant sample. So plant samples, they actually have liquid components in terms of their sample mass. So you can actually use that. Here so we have here 3 replicates of the same sample. So I have mentioned here product 1. So it's just the same sample, but using 3 replicates, or in this same method, same condition. So you're using the same sample, but you need to replicate it in 3 in order to get your standard deviation. So we also obtain the weight of the crucible. So this is already the constant weight. So what do we mean by constant weighing? This means that there is already, or you have minimized the moisture present on your crucible by subjecting it to oven drying and then cooling it and weighing it in an oven. So of course, we also need the weight after ignition. So to get your weight of the wet sample per crucible, you just need to add these two. But after ignition, so this is our measurement. So this is after if you have already subjected it, or you already place it here in the furnace, and then after 2 hours of heating it at 600 degrees Celsius, so we cool it, and in the desiccator we cool we we remove the further moisture so that it will not absorb any more moisture. And then if it's okay for weighing, so we can already proceed to weighing it in an analytical balance. So the weight of the ash, this is actually a calculated measurement, so you can refer to the data here that we have. For the percent ash, I already included here the sample calculation from the standard method. So wherein you have the W1 refers to the weight of the crucible, minus W2, which is the weight after ignition, and WS is the weight of the sample, times 100. So we just substitute the values here. So that's per replicate. We need to calculate the percent ash. And then if we want to get the overall mean, so you can actually get the overall mean and standard deviation for these replicates. Okay, so that's it for the example of R for gravimetry by volatilization. You can also use moisture content determination and other volatilization gravimetric methods.